Right. Integration, the basic idea is it's the reverse of differentiation. Do you want to sit on the other side? Or are you fine?
Okay.
Okay, so for example, in Core 1, we teach you that 5x squared, if you differentiate that, you get 10x to the power of 1.
Mm-hmm.
And so integration is just the reverse process. So we give you that as a starting point and you have to produce that. Okay?
Mm-hmm.
The classic code with which we tell you that you're supposed to do a reverse differentiation is the curly. The curly you just have to interpret as a command to produce something which, if you differentiated it, would give you what's in the curly. So, I don't know, 10x to the power of 4. What could have produced that upon differentiation? It could have been, I don't know, whatever works, 2x to the power of 5. And because constants disappear, there's actually no limit to what could work. These are all fine. And to express the fact that there's a million possible answers, we use a classic device, which is algebra. Algebra, the whole point of it is to enable us to talk about a million examples at once. So what you get full marks for is writing that. Okay, so that's equal to that. Okay, so just bear in mind always that whenever you produce an answer to an integration, you are able to check it by differentiating it and making sure that you get what you start with. Okay. Now, what I've talked about here is just general integration.
Yeah.
There's a special type of integration called a definite integral, which is when there are little numbers there. Now, there are 4 meanings to this. Okay. The first meaning is that. Okay. The second meaning is when you write the basic Core 1 primitive, so in other words, what you would need to differentiate in order to get that, when you write it in squared brackets, and you don't need to write a plus C, but you can if you want. And instead of the 5 and the 2 being atop a curly, the 5 and the 2 go on the right hand side of the square bracket. That's the second meaning. The third meaning is where instead of writing a single set of square brackets, you write a double set of regular brackets, but it's not like a quadratic factorization because there's a minus in between. And you don't write any algebra. In the left bracket, you write this with a 5 instead of the x's. And in the right bracket, you write this with a 2 instead of the x's. So that's your third meaning. Okay, and the fourth meaning is the signed area between x plus 5 and the x-axis between 2 and 5. Now the most normal method to proceed in an exam is to get one of those and to produce the third meaning. But sometimes you might want to bypass these 2 meanings and go straight between the first and the fourth. I'll give you an example. Oops. Until you get to Core 4, it's not reasonable to expect you to do any calculus on that. Okay? But it is reasonable for me to ask you that question. Now you might say, how could it be reasonable for me to ask that if I don't expect you to do any calculus with it? Well, just switch to the fourth meaning. Graph this. That's a semicircle of radius 2. It's been flipped underneath the x-axis. I want to know the area between the x-axis and the curve between 0 and 2. A year 8 could work that out.
Yep.
It's a quarter pi 2 squared. So basically that fella is pi. Okay? Now in year 13 you do have the techniques to verify that that's pi, but I'm saying even in year 12 you could have done that question. Okay? You just switch from the first meaning, the curly bracket, straight to the fourth meaning, which is a signed area. But I've made a mistake there. What's the mistake? Remember, it's signed area?
So it's
negative pi. Okay, so in other words, whenever an area is plain as day underneath the x-axis, you need to take account of the fact that it is going to give you a negative answer. That means that you have to be very careful about working out areas using this integration business. Okay, in this case I was absolutely sure that I got it right because I could physically see the area and I used a year 8 formula on it. But what about this one? If I said work out the area between y equals x, x minus 4 and the x-axis between negative 1 and 3, I can totally see why students would write that down. It's because they've been taught that this curly and area are the same thing. But the problem is that it's signed area. And so if you actually want a real area, like a proper area, you need to be aware that this will only give you a signed area. Okay, so the way around it is to be jolly sure where this crosses the axis. Crosses at 0 and 4. So we want that, and a little bit of that. Yeah? So what I recommend is do it twice. Work that out. Yeah? You'll get that fella.
Yeah.
Then work this out. You will get a negative answer, I don't know, negative 2.3. But that will tell you that the real regular area of that is 2.3. So if that gives you 0.7 and that gives you negative 2.3, the actual real area will be 0.7 plus 2.3, in other words, it will be 3. Okay?